I'm Sammy.
I'm Carolyn.
I'm Esther.
Hi, I'm Joy.
Does this? Okay, I'll just bend down then. Sorry, I'm a little bit taller. So before we get into our project, I'd just like to start off with talking about why we chose this topic. And so each of the members on our team, we have some personal relation to the issue we decided to tackle today. For me personally, this is my uncle. And so my uncle is one of my favorite people in the world, but he also has a lot of health issues. One of his most serious health issues is that his kidneys don't work. And so thankfully there is a life-saving treatment for this. It's currently called dialysis. And after getting a couple of transplants, them not working, he does rely off of this dialysis treatment. So for those of you who might not know what this looks like, we wanted to show you a short video to give you a bit of insight into what life is like as a dialysis patient today.
But Misty Dudley needs a kidney nonetheless, and she needs it badly.
Anybody's hoping not to come to this.
This is dialysis, a satellite clinic in Chatham that 26-year-old Misty calls home 3 days a week, where a machine cleans her blood much like her kidneys are supposed to.
What your kidneys are doing, mine aren't. So I need a machine to help.
Misty takes an active role in her care, recording health statistics and resetting the machine. But managing her health has become her full-time job, a big step away from the social worker she aspired to be as a teen.
I had to take a whole new path. Not being able to go to college, with having to come here, having to deal with the different specialists, and then eventually not being able to work anymore.
Right now, she only has one.
Yeah, so as seen in the video, how dialysis works is that it essentially functions as an artificial kidney outside of the body. And so even though this treatment does work, it is like a very consuming illness. Like, for example, my uncle, he has to leave the middle of his work every single day for a couple of hours of this treatment. He can't commit fully to taking care of his daughter because when he comes home, he's really tired and fatigued. And our project is trying to find an alternative solution to this.
Here are some statistics on kidney transplants and dialysis. Dialysis costs on average $89,000 yearly, but the average American only makes $56.5 thousand. Last year, 100.7 thousand people were on the waiting list for a kidney transplant, and every minute 14 people are added. Yet last year, only 17,000 kidneys were donated, and in fact, 13 people die every day waiting. Our inspiration behind the project is a salamander's ability to regenerate its limbs and organs. They're able to revert their cells back to their general stem cell form using a process known as dedifferentiation. Then the stem cells are redifferentiated back to its specialized parent cell form through cell division. This is made possible due to macrophages, specialized white blood cells.
And so the way that our proposal would work with organ regeneration is that we would be utilizing CRISPR, a gene editing technology, to replicate the organ regeneration properties that salamanders and other other animals have. And so first thing that we would do is that we would use this sort of technology to allow the genes in kidneys to reverse from their parent cell state into their stem cell state, and replicating what salamanders are able to do with their bodies. Once you have that stem cell state, you can actually reform and regenerate into any sort of cell that you want.
So after doing this, we would surgically remove the damaged parts of the kidneys. Not necessarily like the whole kidney needs to be removed at all times. Sometimes it's just different parts, and we'll explain that later of different cases. And then after this, since you are growing like a new organ inside your body, our estimated time is it would take around 6 to 2 years to fully obtain development and functionality of what you're trying to obtain.
So for our proposal, kidney regeneration, we observed two main causes of kidney failures. Case one is high blood pressure. High blood pressure is caused from a long-term force of the blood against the artery walls. Because of this, the blood vessels wear down. This prevents kidney from being able to remove waste in the blood, which builds up to dangerous levels and cause heavy damage that is not reversible. Treatment can be medication and lifestyle changes. Because high blood pressure is similar to diabetes, it can also be used for diabetic patients. Our solution for high blood pressure is to repair the kidney's blood vessels and capillaries. Case two is physical injury. Usually, physical injury is caused from accidentally rupturing the kidney due to a high contact force. Treatment would be kidney transplant, but this causes risks such as bleeding, rejection, infection, pain, and nausea. Our solution for this would to regenerate larger sections of the kidney, but in severe cases, it'll lead to a full regeneration of the kidney.
So Joy and I were able to use the VR simulation, and we used the program called Tilt Brush to actually draw out what a healthy kidney looks like and what a damaged kidney looks like. So as you can see, on the right is the healthy kidney, and then on the left is going to be the diseased kidney or the damaged kidney, and the yellow stuff is kidney stones, and on the top right is a tumor. And then on the left, you can see a whole bunch of cysts forming on the kidneys, and on the right, it's completely healthy. So in our next video, we're going to show basically what would happen after you implant the reprogramming of our genes to replicate what salamanders are able to do. And this is after you surgically remove the old kidney. So this is what it would look like when it's finally growing into a healthy kidney. So as you can see, it's exactly like the healthy kidney on the right, and it obtains the same properties and abilities. And this is only in severe cases, because sometimes you only need to replace capillaries or different sections of the kidneys. But in this case, we're replacing an entire kidney.
So in conclusion for this proposal that we have today, currently there are still scientific setbacks. So research is still being done to find out precisely how salamanders are able to regenerate their limbs. But we believe that after we're able to precisely locate or to figure out how that works, we can reverse engineer that technology into our own organs. Another idea that we wanted to bring up was this concept of micro or nanobots inside of our vital organs. And so one thing about kidney failure is that a lot of the symptoms only show up when it's too late. And so to be able to track something like lower blood or high blood pressure or low blood pressure in the kidneys, toxin levels in the blood would really help us with diagnosis and also supplement our proposal for this technology.
We really hope that technologies such as these will help provide a more comfortable and effective solution to patients suffering from kidney failure.